Okay, 7.2 has, like I said, a lot of parts in it. This is the disk method. I showed you this in class. The formula actually is the radius of the function squared. That's horizontal with respect to x, and if it's vertical, perpendicular to the y-axis, it would be the radius function with y with respect to y. Okay? Now, we have a question, we have a problem here. We're going to take y equals the square root of x around 0, 4, or our limits of integration would be 0, 4, and we're going to rotate it around about the x-axis. So what we're going to do is we're going to plug it in the formula, and this is what we get. The picture that we get looks like this, okay, where this is 4, okay, square root of graph right up to 4, and then when we rotate it, we get that cone-looking thing. So to do this problem, let me get my notes here, not too bad, because it's just going to be x, the square and the square root undo each other, so this is going to be pi times x squared over 2, evaluated at 4 and 0. Well, at 0, it's nothing. At 4, it's just 8 pi. So this is 8 pi cubic units. Done. I know I made it look easy. And I promise you I'll give you some practice that it's a little bit easier. All right, let's do another one. More practice. This is the disk method. And I guess the best way to say the disk method is that there's no space, okay? There's no space between the line that it's rotating about and the figure. There's no space at all, okay? That's going to differentiate between a disk and a washer. I don't care what I said in class. That was a better explanation I got from somebody. Let's do another one. This is y cubed from -1 to 1. Now, the limits of integration are given. A lot of times they do give you the limits of integration, so you don't have to solve for it. So this is just going to simply be pi times from -1 to 1, all right, x cubed squared dx, because we're still going about the x-axis. So this is going to be x to the 6th. So then when we go ahead and take the integral, it'll be pi x to the 7 over 7, and this will be evaluated at 1 and -1. Well, when I do that, I'll get 1/7 and then minus a -1/7, so I'll get 2/7 times pi cubic units. Nice. Let's do another one. The square root of the sine from 0 to pi about the x-axis. So what I will do is I will say, okay, this is going to be pi times 0 to pi of the square root of sine x, all of that squared dx. Comes out nice because when I do that integral, it's going to be negative cosine of x. Because remember, the square root and the square undo each other. The integral of sine is negative cosine times the negative pi. And we're going to do this from pi to 0. Now from pi, it's going to be negative pi cosine of pi. Cosine of pi is -1. So this is going to actually be just pi. And then when we do minus, it's going to be minus negative pi. And the cosine of 0 is 1. So this whole thing turns out to be 2 pi, and that's cubic units once again. I'll emphasize that it is volume, a volume of revolution. All right, does anybody have any questions? I can't hear you, so it doesn't really matter. All right, we're going to revolve about a non-axis line, okay? So it's still going to be a disk, but it's going to be about y equals 1. So instead of the x-axis, which is y equals 0, this is y equals 1. All right? Well, this one doesn't tell us the LOI, so we have to find it. So in green, I will find the LOI. The LOI is setting them equal to each other. Equals 1. So this turns out to be, I think, x squared minus 1 equals 0, so it's plus and minus 1. That's our LOI. Okay? So it's going to look like, and this is a parabola. So in my head, I've got to think that what's happening is that it's a parabola and a line. So we're going to take this and go along a line. Or that line is actually a straight line. And now we're going to go about that line. So it's going to be by that line. Okay, it stops on that line, and that's the line we're going to rotate about. So it's still a disk. You have to think about that. You have to think about it being a disk. All right? If you have to graph it, then graph it. But I just thought about it. I know it's a disk. So I'm going to use the disk formula. And I'm back to red here. I'll do it in red. It's pi. It's from -1 to 1. And it's going to be 2 minus x squared. But wait a minute. 2 minus x squared. Okay? But since it went up 1, I have to take that away from it. All right? Since I have to take the space that's above the x-axis away. So it's going to be 2 minus x squared and then minus 1, quantity squared. And like I said, this is the space, how far above it is. By the way, no, that's fine. It's fine. So now let's do it. This becomes 1 minus dx. And this becomes 1 minus pi, -1 to 1, 1 minus x squared dx, quantity squared. And that's going to be, inside, it's going to be something crazy like 1 minus 2x squared plus x to the 4th dx. And now it's getting crazy. And now we have pi times x minus 2x cubed over 3 plus x to the 5th over 5, all evaluated at 1 and -1. When that smoke clears, you should get 16 pi over 15 pi, or over 15 cubic units. So once again, the only difference here is when you have another line, a non-axis line, okay, we have to account for that. So we take away the 1. If it was up 2, we take away 2. That's it. All right? Because we want the distance. Next, we got some homework here, but I'll talk about that later. I want to look at washers. All right? You know what? Let's do this homework too. Some of this we will do in class. Let's maybe leave. Let's have you do these for homework. Okay, 1 to 4, 7 to 10 using disks. And you know what I'll do on this? I'll leave. This is probably, I'm hoping, because this is just kind of on my slide here. I mean, I'm assuming this is going to be the answers. So you have the answers and you have the questions. Then we could talk a little bit tomorrow. Now I want to talk about washers. Washers have holes, but more importantly, what I found out today, this doesn't have a hole. That would be revolved and it would be like a cone or something. And it wouldn't have a hole in the figure. However, the hole I'm talking about has some space. Okay, that's better. I don't like the word holes anymore. I've been teaching it for years with holes. This has some space between the graph and rotation line. Okay? That's what makes it a washer. A washer has 2 radii, has a smaller one and a bigger one. So when I go and do my formula, it becomes the volume is equal to the pi, A to B, outer radius minus inner radius. And I denote that with a capital R, lowercase r. Sometimes these radii have to have numbers in them, especially if they're on different lines. But we're going to do some easy ones here first. Let's do this one. Let me make one up here. Let's do y equals the square root of x, y equals x squared. Okay? We're going to do this example. First thing I have to do is find the LOI. So the LOI is to set them equal to each other. So I'll say square root of x equals x squared, square both sides, and then move them to the one side. So it'll be x equals x to the 4th, 0 is equal to x to the 4th minus x, factor out an x, and I have x cubed minus 1 So my answers can be 0 and 1. That's my LOI. Perfect. So I have pi, 0 to 1. Now, which one is the outer radius? Well, which one's greater? So take a number between 0 and 1. I'll take a half. If I put a half in here and a half in here, this guy is bigger. So it's going to be the square root of x squared minus x squared squared, dx. So now, I want to change colors, you don't mind. So now it's going to be this, 0 to 1 of x minus x to the 4th dx. We keep on trucking here, and this becomes pi times x squared over 2 minus x to the 5th over 5 from 1 to 0. And when the smoke clears, you get 3 pi over 10. Make sure you can get that, cubic units. And we just did a washer. Let's do another one. I'm only doing one more. Okay, the next one I'm going to do is this one. This is a semicircle. Okay, let me get my notes. I missed my notes. There it is. Okay, this is a semicircle and 3, and it's going about the x-axis. So when I go to look at this, all right, y equal, whoa, nearly. When y is 3, this is actually something that goes from here to here. Okay, and it's the area here. That's what it's looking like. Okay, I don't know the LOI, so let me get the LOI. The LOI can be found by doing this. 3 equals the square root of 25 minus x squared. Square both sides. Okay, square both sides, and I'm going to get 9 equals 25 minus x squared. Then I'm going to subtract the 9, move the x, and basically, I mean, I think you can see x needs to be 6. This needs to be 16. So this is going to be x equals plus or minus 4. I'm sure you could do some factoring. So now, and actually it becomes symmetrical. All right? But we're going to go from -4 to 4. That's how it's going to work. So our integral is going to be from -4 to 4. Let's talk about the outer radius. The outer radius is this guy. That's the function. So that is going to be the function 25 minus x squared, quantity squared. Then minus, let's think about the inner radius. The inner radius is just that line. So the inner radius is 3 squared dx. Good enough? Outer, inner, now we're going to go. And the answer turns out to be, because I don't want to go through it all, but the answer turns out to be 256 pi all over 3, and I'm talking cubic units. So make sure you can get that. So when you're doing these problems, make sure when you watch this video, maybe pausing it and making sure you can get this stuff, okay, before we go on. Okay, what I want you to try, we have one more to do here, and this is a special case, all right? You don't see this very often. You may never see this again, but I would be remiss without showing it to you. So maybe this is for your viewing pleasure, but just know it could happen, all right? And what this is integrating with respect to y to integral case. You know what? Better yet, I'm not going to confuse you. Let's stick with washers, and let's stick with discs, and let's get some homework going. I gave you homework from discs before. For washers, I want you to do the following. 5, 6. Let's do 11. I'm looking at it right now, so I don't screw it up. Okay. Let's do 11. Forget about A. You're doing all. We did 11 actually, so let's forget 11. Let's do 12, 13, 14, and let's do. This said 29. I don't care. I don't want 29. Let's do those. All of these problems on page 465. So you've got some problems to do here.